Yes, good day, everybody. Thank you for taking part in the press conference from the World Meteorological Organization, and thank you to UN Television for hosting. We are having this technical briefing today not because we have a new report, but we've been getting a lot of media inquiries about the extreme temperatures that we have been seeing. So this is, in response to journalists' interest. I will present the two experts from the World Meteorological Organization. On my right is Dr. Omar Badour, who is Chief of WMO Climate Monitoring. It's Dr. Badour who coordinates all the WMO State of the Climate reports, and obviously most of you know him. This press conference will be in English. If there are questions in French, Dr. Badour is Francophone and can obviously answer them. Then to my far right is Dr. Michael Sparrow. He's head of the World Climate Research Division at the World Meteorological Organization. Again, an expert of many years standing, and Dr. Sparrow has a specific focus on what's happening in Antarctica. And as we will see in this briefing, both on land, at sea, and also in Antarctica, there are developments which are of great concern to the scientific community and indeed to everybody. Dr. Badour will say a few words. He will then have just a few, I think 5 or 6 slides, just to help you picture, the scale of the changes that are taking place. So without further ado, Dr. Badour.
Thank you, Claire. Good afternoon. So today is a part of the WMO role in providing climate services for the international community through you as a media. As you know, WMO monitors the climate system on a daily basis using a range of observing platforms in the land, in the sea, and the atmosphere. And today we are going to show you some silent events, silent information that came in last few weeks, including breaking records on temperature on daily and monthly basis, as well as the breaking record of temperature in the North Atlantic Ocean, as well as the breaking record of sea ice melt in the Antarctica. So let me start first by saying that June 2023 was just over 0.5 degrees centigrade above the average, and this is the record June, this is the record June ever recorded. And also the sea surface temperature was very warm since the month of May. We recorded El Niño, which now is officially set, according to the latest WMO release in past week. And also the North Atlantic temperature reached record. The This is an unprecedented, as you will see in the graph. We recorded more than 1.5 degrees centigrade above the long-term average of sea surface temperature in that ocean. The Antarctic sea ice is dramatically showing low record. As you might be noticing in the past years, the Antarctic sea ice was a little bit stable until 2016, when we started looking at very low extent in 2016, and then continued throughout the years, except some ups and downs in some years. And this year also we noticed a very dramatic low extent in this month. So can I start with some slides to show you more details, and you can see that very illustrative manner. So first slide is actually showing, can I have the slides clear, please? So I would like to start by emphasizing that the data that I am going to show is actually based on a range of observing systems. While waiting the slides, just as an intro to that slide, WMO set an observing system since its inception in more than 100 years. And this observing system evolved with time. And currently, we are based on several observing systems on land, on air, using satellite, and using marine ships, buoys. And all this data actually is analyzed in various ways. One, by direct looking at the data itself. And the other way is to use what we call reanálisis data, which assimilate all this data into one supercomputer and applying dynamical and thermodynamical equations, and then come up with an estimate of what the state of the climate is. So next, please. So the next slide shows actually the June temperature, the monthly average June temperature anomaly with respect to long-term average, 1991-2020. This is the base period that WMO used to compute the variation of the climate system. As you can see on the far right, the bar showing that June was extremely hot compared to past years, breaking all records. Next, please. So the next slide, actually, I try to explain to you why June was very warm. Looking at the sea surface temperature, I am looking, you have here two oceans, the Pacific on the right and the Atlantic on the left. As you can see on the right, a very large area in the central equatorial Pacific with temperature above 0.5, reaching 3 degrees centigrade above the average along the coast of Peru and Central America. This is a very typical pattern of El Niño. As I said earlier, El Niño is officially declared, and it has a large ramification around the world, including the increase in temperature. On the left, as you can see, this is where we have actually a very unprecedented feature in the climate pattern is the North Atlantic. Very warm, warmest June on record in that ocean. That has a lot of applications, including on weather system, tropical cyclones, and marine heat waves. Next, please. So this is actually a more illustration on what happened in sea surface temperature in the North Atlantic. This time series, as you can see, these plots provides you the usual sea surface temperature in the Atlantic in the past decades in different colors. The solid line in black is actually what happened in June. Daily June temperature in the North Atlantic, as you can see, is dramatically high compared to the past behavior of that area. So we record an unprecedented peak of temperature in that part of the world. Next, please. So actually, as we go with long-term climate change, we also being noticing some dramatic changes in the various components of the climate system, including the sea ice. It's not only, it's too early to say that it's associated with climate change, but there is certainly some signature that scientists should discover in coming years. But what we can see is a dramatic change in the sea ice extent in Antarctica, as opposed to the regular sea ice extent depletion in the Arctic, which now we are used to. So in the graph, as you can see, 2023, sea ice extent is very below the previous records, including the 2022, which was also the record. So to put that into context, about 2.6 million square kilometers of loss of sea ice compared to the long-term average, and almost approaching 1.2 million square kilometers below the previous record, which was set in 2022. This is a really dramatic drop in the sea ice extent in that in the Antarctica. So the exceptional warmth of June and the start of July occurred at the onset of the El Niño, but also in the context of the long-term climate change that now is proven unequivocal and due to human influence. And next, please. So this is my last slide showing the breaking the planet record of temperature in early July. So according to various data sets from our partners in different parts of the world, the first week of July set a record of daily global temperature. Currently, we assess it based on data from the European Copernicus datasets, but also from NOAA and from Japan. We assessed that the record was broken in 4th and 7th of July with a temperature close to 17.2. And if we compare that to the hottest day in the past, which was recorded in August 2016, as you remember, 2016 was an El Niño year, that was 16.9 degrees centigrade, so a difference of about 0.3 above the previous record. So this is all I can put you in the picture, but as you know, we are going to monitor the situation, including the El Niño as well as the state of the climate before the release of the annual state of the climate report, which is expected to be launched at the occasion of the COP28 of the UNFCCC. Thank you very much.
Thank you. Dr. Sparrow, would you like to add something from your perspective?
Thank you very much, Claire and Omar. I think when I see when you see Omar's presentation, you do see, like, for example, his last slide, it showed that we've very recently crossed, the warmest temperature in the day since records have begun. I would say that's not unexpected when you look at what the scientific community have been telling us over the last 20 or 30 years. We would expect that we're going to start crossing boundaries and keep hitting the world's warmest day as we move ahead. However, what I find a lot more concerning, and unprecedented is probably a word that's overused in the media when it comes to climate change, but as an oceanographer myself and somebody who did his PhD around Antarctica, when I see the kind of temperatures we're seeing in the North Atlantic at the moment, they really are way above anything that the models have kind of predicted as we're going forward. And the sea ice extent in Antarctica, you can see a lot of other graphs from people like Zach Labe online. There really is completely unprecedented, this kind of reduction in sea ice that we've seen around the Antarctic. The Antarctic region is normally thought of being relatively stable. It's much colder than the Arctic. We're used to seeing, you know, these big reductions in sea ice in the Arctic, but not in the Antarctic. It's around about 5 standard deviations for the mathematicians around here, below what we would expect or we have seen in the past. And this is a massive decrease. And the scientific community is struggling to a certain extent to keep up. I see a lot of things online in social media with scientists being incredibly concerned about particularly the ocean temperatures and the reduction in sea ice extent. Because we have to remember that the oceans absorb more than 90% of the excess heat that humans put into the atmosphere because of greenhouse gases. So that's where we need to make these reductions. But if the oceans are warming considerably, that has a knock-on effect on the atmosphere, on sea ice and ice worldwide. So yeah, there's a lot of concerns from the scientific community and a lot of catch-up in the scientific community trying to understand these incredible changes we're seeing at the moment. And it's very concerning.
With that, we'll go to questions. First, we'll take a couple of online ones and then we'll go to the room. So Isabel Sacco from the Spanish news agency EFE.
Good morning. Thank you very much. Please, I would like firstly, if you can repeat the numbers you gave, you mentioned on the reduction of the drop of the sea ice around Antarctica. You gave 3 figures, so if you can repeat them. And secondly, Mr. Sparrow, if you can develop on what are the consequences if about what we are seeing on the rise of the temperatures in the ocean and the fact that they can less absorb CO2, and what would be the consequence for the atmosphere and for the global heating. Thank you.
Thank you very much. The graph I showed on the screen with respect to the Antarctic sea ice, there are one map which shows the extent compared to the average. And you can see along the Antarctic circle, there is a depletion of the cover of the sea ice extent. And the graph which shows the evolution of the sea ice extent since during the annual cycle of the Antarctic sea ice, there was a curve, blue curve, which shows values below the long-term average, but also below the record broken last year in 2022. So this is a depiction of a dramatic evolution in the Antarctic, as my colleague Dr. Sparrow mentioned, and scientists are going to look at that. What are the dynamic components of this, and what is the long-term climate change component of this? It's today too early to attribute that to any of these 2 components, but certainly the climate change is going to alterate most of the component of the climate system, according to what the International Panel of Climate Change has already concluded. So it's just a matter of few months or few years to come back again and say this is actually a signature of climate change. Thank you. Mike.
Thank you. With regards to the effects of the warming ocean, or the unprecedented warming ocean, in the Pacific region, as Omar showed in his slides, we're used to how we study the El Niño and La Niña phenomena. So during an El Niño year, heat moves from the ocean to the atmosphere, and this is well studied. But during an El Nino year, you also have effects on fisheries across, not just in the Pacific, but across the world. What is very unusual this year is the degree of heat we're seeing in the North Atlantic. So you're seeing temperatures, a marine heat wave of more than 5 degrees C around the United Kingdom, for example, on areas around the United Kingdom. This will have a knock-on effect on ecosystems, on fisheries, etc. As well as you have to remember that the oceans have a much higher heat capacity. They hold a lot more heat within them than the atmosphere does. And when the oceans are particularly warm, it means that they warm the atmosphere considerably as well. So we'll see effects on fisheries. We will also see effects on extreme weather events as we go ahead, and extreme warmings of the atmosphere as well.
Imogen Fuchs from the BBC, and then I'll take a question in the room.
Hi, thanks for taking my question. I was also wondering about the consequences of this extreme temperature rise in the Atlantic. Like here in Switzerland, obviously we're landlocked, but they had to take loads of fish out of the rivers last year because they were going to suffocate because the rivers and lakes had become too warm. Is that the kind of thing you fear, the effect on the fish population in somewhere like the Atlantic, were this to continue?
I should emphasize, I'm not a biologist or an ecosystem person. I'm a physical climate scientist. But yes, certainly, there has been studies in the past when you have these marine heat waves, they certainly do affect the fisheries and the ecosystems in the oceans around. And as you mentioned as well, when you see unprecedented warming in the oceans and in the atmosphere, that also affects landlocked countries such as Switzerland. Melting of glaciers, affects the ski season if you're, the economy of Switzerland, but also can affect the ecosystems in the lakes and the rivers as well.
Thank you. Do you want to add something? Dr. Badeau will just add something on that.
In addition to that, I would say also the North Atlantic is one of the key drivers of extreme weather in Europe and also in the other side of the Atlantic. Actually, with warming North Atlantic, there is likelihood of increasing frequency of hurricanes and tropical cyclones. And also, if you go down south, the North Atlantic sea surface temperature actually was associated with occurrence of heavy rain or drought in the West African part of Africa. So through that mechanism, we can see how major impact could we expect if the prediction confirms this to continue in the next few months. On the when you have a tropical cyclone, everything is affected on the shores, including fisheries, but also including inland, with heavy precipitation that could lead to casualties, displacement of population, and so on. So if we say that is a dramatic change, that means also dramatic likelihood of extreme weather and climate event. Thank you.
Thank you, yes. In the room, yeah. If you could just introduce yourself, thank you.
Okay. Thank you. I'm from China Media Group. My question is, El Nino phenomenon is normally associated with high temperature globally. But now we are just at the beginning of the El Nino, and now we have had a high temperature June on record globally. So do you think in near future we'll suffering more and more like a high temperature July?
Yes, no, you're exactly correct. And that's a point I actually meant to make, that in fact, El Nino does drive atmospheric temperatures. During an El Nino year, you get higher temperatures in the atmosphere as well, because heat is moving from the oceans to the atmosphere. But as you correctly pointed out, we're actually only just at the beginning of that process. So El Nino hasn't had as much of an effect as it's going to later in the year. So we're seeing these high temperatures in the North Atlantic, etc., despite the fact that El Niño hasn't really got going yet. We can expect much higher temperatures from the El Niño in the latter half of the year in sort of October and November time.
Yes. Also, we usually the warmest year is expected to be after this year. So the El Niño year actually is between 2 years, 2023 and 2024, where we expect the El Niño will pick up. And then if there is an expectation of whether we will reach a record year, that is a question likely to happen in 2024 if the strength of El Niño is going in the way that is predicted currently. Thank you.
Robin Millward from the French news agency AFP.
Hi. If you could say perhaps a little bit more about what we can extrapolate from these high temperatures about the broader state of the climate. And secondly, we can see these very high temperatures now, but are they part of a trend which suggests that they're going to be even higher? Can we, to what extent can we see this coming, that temperatures will be even higher in the future? Thank you.
I will start, and Mike perhaps will provide more in-depth scientific answer to the question. WMO issued annual to multi-decadal climate prediction, and also in collaboration with UK Met Office and other organizations. They predicted that there is 66% chance that the 2023-2027 period be near or above 1.5 degrees centigrade. And there is a likelihood of breaking the record in this 5 years period. And also there is more than 90% chance that one of the years within that period will actually be above 1.5. So this is only part of the long-term trend of climate change. In the past few years, actually, we have felt some kind of stagnation of the global temperature. I would say thanks to the opposite La Niña event, which put some break in the temperature globally. Despite La Niña, we have recorded several breaking temperature at limited scale. For example, in Europe, several countries already recorded their temperature records, and also we recorded several extreme events. So if La Niña has give us a chance to not see a spike in global temperature, I think El Niño, the current El Niño, gives all the criteria that the global temperature will actually is going to break that record again. And as you might remember, the record year currently is still 2016, which was one of the warmest year, one of the intensive El Niño year, and adding to the long-term trend, El Niño just give another spike to the long-term trend in temperature. Thank you.
On the line, I have Christian Ulrich from. Before we go to you, Christian, we'll just go back to Mike Sparrow.
Sorry, just very quickly to add what Omar was saying. As I mentioned before, the global climate models we use to predict the climate system do a very good job of predicting what the future climate is going to do. Having said that, the climate system is also very complicated, and sometimes the Earth, the global climate system, throws up surprises. A good example was, the rapid decline in Arctic sea ice was much quicker than the global models at the time predicted. And so the scientific community, moved to try and understand why there was this rapid decline in the Arctic, and updated their model systems to take this into account. I would say that, at the moment, the scientific community is in that catch-up phase, trying to understand why the North Atlantic, for example, is so much warmer than the models are kind of predicting. And also, you know, again, the other extreme example of the Antarctic sea ice extent is much lower than any of the models have predicted. So again, the science has to catch up with what's going on in the Earth system. But unfortunately, you know, these surprises, the Earth system does throw in these surprises, but they tend to be not surprises that help us. They tend to be, you know, things tend to be a little worse than or much worse than we actually predict.
Thank you. And so the German press agency, Christian Ulrich.
Thank you, Claire. Thank you for the briefing. I'm trying to recap. Is it correct that El Niño in the past did not have an effect on the temperatures in the North Atlantic, that this is the first time the temperatures are rising with an El Niño? And more specific to the Antarctic, are there tipping points where you think ice is irretrievably going to be lost, and are we getting near them? Thank you.
Thank you. So the first question, I mean, whether in the past, in an El Nino year, we've seen higher temperatures in the North Atlantic, that's a little bit out of my area of expertise. I can say that during El Nino years, certainly we see temperature changes worldwide, both in the oceans and in the atmosphere, because the global ocean is interconnected. And so if you see warming in one ocean basin, such as the Pacific, you will see changes, warming or cooling, in other areas of the ocean basins. I think it is clear that at the moment, the warming we're seeing in the North Atlantic doesn't seem to be connected to El Nino, not directly. So we're still trying to understand why we're seeing such an extreme warming in the North Atlantic. And your other question about the Antarctic sea ice, I mean, you brought up the aspect of tipping points. Obviously, there's a lot of work in the scientific community, and the IPCC are considering a special report on tipping points, whether that's Amazon dieback, whether that's, for example, sudden collapse of the West Antarctic ice sheet, for example. So this is obviously something that's concerning the scientists, but we don't have the evidence to say, oh, we're entering some kind of tipping point at the moment, because this is still new, and we don't want to make suppositions without having all of the evidence to hand, which may take some time, of course.
I've got one question from an online chat. It's from a journalist watching the UNTV broadcast. And the question is, how many days did Copernicus report as being the hottest on record in the past 7 days? Combined with the University of Maine dataset, can we have confidence in these preliminary results?
We looked at several data sets, including from Copernicus, from NOAA, from Japan, and from others. Currently, the consensus is that 4th of July is warmest globally. In recent days, I have not yet get the confirmation from all the data sets that I have mentioned, but at least looking at the Japan reaanalysis data, which is also one of the WMO partner in producing the state of global climate, it looks like, at least as a preliminary results, which has been assessed within WMO, that 7th of July actually is more than 0.1 degree, 0.01 degree above the 4th of July. So what I can say is that the first week of July, starting from 4th to 7th, could be considered as the warmest period or the warmest week ever recorded. Thank you.
Thank you. Are there any more questions, either in the room or online? Christian Ulrich from the German press agency has another question.
I'll take this opportunity if there's no one else. Thank you. We have been talking about the ocean and the Antarctica. Can we talk about Central Europe? What do you expect in the next 6-8 weeks from the heat in the North Atlantic and the other phenomena that you have been describing? Thank you.
In Europe, we have very good infrastructure for making prediction, and Germany actually is a leading node on climate monitoring for Europe. And the issue usually what we call climate watches. It looks like there is a likelihood of having precipitation above the average in some part of the area. So for the moment, it's very preliminary for us here in this room to make a prediction, but we will keep updates through this product produced by Germany, whether we are heading to some extreme rainfall in Europe. Southern Europe, currently, as you may have noticed, and North Africa are experiencing drought conditions, plus extreme heat waves, reaching 47 degrees in Morocco in last few weeks. And so I think perhaps I just extrapolate. When you have such dramatic change in the North Atlantic, so many weather patterns will also respond to, either towards extreme rainfall because of excess of moisture flowing from the Atlantic to European side, or through changing the weather pattern that can change actually the precipitation also in the North African continent with perhaps exacerbating drought condition. Thank you.
We have another question from Imogen Fuchs of the BBC.
Yeah, Mr. Sparrow, you said it was too early to say if we were at a tipping point and that would need more analysis. I'm just wondering, I mean, what is a tipping point? What would it look like? What would happen?
There's not one, I mean, there are several different potential tipping points in the climate system. There's been quite a lot of analysis done by Johan Rockström and others, Tim Lenton in the UK, for example, analyzing, you know, the different types of potential tipping points worldwide, whether that's a dieback of the Amazon, whether it's a collapse of the West Antarctic ice sheet, which could produce, you know, 3 to 4 meters of sea level in a matter of decades, etc. But the issue is that so far, I would say we don't have any strong evidence that we're hitting any of these tipping points initially, but there's more research that needs to be done. One of the aspects is the fact that you need to be able to monitor these regions. In the Antarctic, obviously, it's extremely difficult to monitor what's going on in the Antarctic because it's remote. The weather is very extreme as we go forward. So I think there needs to be a lot more, you know, investment in the science and the observation system in understanding you know, what could potentially happen and monitoring, as Omar has shown, what's going on worldwide. You know, we have good monitoring systems in Europe, for example. We don't do very well on the African continent, around in the polar regions, particularly in the Antarctic, etc. as we move ahead. So I don't think I can say much more about that because it depends on the tipping point you're talking about.
Okay, I can't see any. Oh, yes, I can see one question. Sorry. Back to the French news agency, AFP.
Thank you. Normally when weather records and temperature records are announced, it takes a long time before the WMO verifies that and confirms it as a record because of all the checks that need to be done. So how can we know about these temperature records so quickly and to know them with confidence? Thank you.
Very good question. Actually, WMO assess the records at local level. For example, the warmest location in the world. And this needs going back to the history to compare with previous records, and that needs assessing the data and the documents that record this data before announcing that's the case. However, what we are announcing today as June as being the hottest day globally, it's not at local station, but globally, the average of global temperature in June, which is produced, as I mentioned earlier, by a combination of different observation systems in the ocean, in the air, from satellite, from aircrafts, buoys. And the models provides us the best available tool to produce that global assessment on daily basis. It's very difficult today to use only observation at station level to pronounce such record, especially when looking at gaps in the global coverage of stations. For example, in Africa, as my colleague Dr. Sparrow mentioned, there is gap of observation there, in the desert, as well as in some of the polar regions. So the models produce using the best available supercomputing facilities and the best available models based on best available knowledge produce actually a very good way to assess a global temperature on daily basis.
I think with that, I think that's all the questions now. So thank you, Dr. Bador, thank you, Dr. Sparrow, and thank you to everybody for taking part in the press briefing by the World Meteorological Organization. We did post a sort of news item on our website on Friday. We will update it, hopefully, in the coming minutes after this press conference with some up-to-date information, and then I will update it once again later on today. So please stay tuned, because we probably will have more records in the coming days. And as my colleagues have said, we're monitoring it. Thank you.
Recording stopped.